So if you want to show attraction, the arrow would be D. We are doing questions on electromagnetism. I'm selecting basic electromagnetism questions. These are the MCQs. The diagram shows the magnetic field around wire X, which can carries a current into the paper. It's again a case of Fleming's rule.
The previous one was D.
Yes. Your answer was right. And the diagram shows the magnetic field. And look at this diagram. This is again a magnetic field around a straight wire. You have to use Fleming's right-hand rule, right-hand grip rule. Magnetic field is clockwise. Current is in the page.
The north and south aren't looking correct.
The point is that these are the curved arrows. I have given you you people the idea that the arrows are like this. I made more arrows so you can see. I am making more arrows for clarity. These arrows.
Is it?
A small negative charge. The arrows on the field lines show the direction of the force on a small negative charge, a small positive charge. Actually, why you are selecting C and D? Because it's a magnetic field. So why not A and B? Why we are not selecting A and B? These arrows are like this. So they are showing the force on a north pole. Actually, negative and positive charge are not here. Small negative or small positive, if you put them here, if there is a charge sitting here, it won't experience a force until the charge is moving. P and Q represent two parallel. Oh, we have just done it. It's a repeat question. A beam of alpha particles are positive particles. I am telling this for reference. Alpha particles are positive and enters the magnetic field between the poles of a magnet. if alpha particles are going to the right, remember the current is then, the current always take the direction of the positive charge. Current takes the direction of the positive charge. Look this is current. Magnetic field is always north to south. Two directions already taken up. Now, what would be the direction of the force down the page? Down the page is already north to south. So that will be rejected. Up the page. Up the page is again on the same plane, that is vertical. So that is rejected. Now you have to use left hand rule. The current is to the right. Current is to the right, magnetic field is downward. So I make the left hand rule. The first finger is downward.
The question isn't there.
First finger is downward. Second finger is the current. Then thumb is going inward, which is showing the force. So if you put your left hand, it will be pointing inward.
It's B.
The diagram shows a current carrying wire in a horizontal magnetic field. Which arrow shows the direction of the force experienced by the wire? Magnetic field is taking this direction. Current is coming towards you. Remember, the force cannot take the arrow of the current. Force cannot take the arrow of the field. So I will reject A and C because they are parallel to the field. Force cannot take the arrow of the field. Force cannot take the arrow of the current. So two are rejected. Only B and D are left over. Current is coming towards you. Current is coming towards you. And magnetic field is left to right. Magnetic field is left to right. So magnetic field is, this is field. Current is coming towards you. This is current. And the thumb will be pointing upward, the force. So the answer is B. We move to our next question. Two long parallel conductors carrying current lie in a horizontal plane. The two conductors attract each other. So when two conductors are parallel and they are attracting each other, the currents are in the same direction or opposite. It's a memory call. Same direction. Very good. So what should be the answer?
It should be A.
Good, Ahmad. A wire hangs between the poles of a magnet. When there is a current in the wire, in which direction does the wire move? Magnetic field is always north to,
Sir,
yes,
is it again a Fleming's left-hand rule?
yes. And you can see Fleming's left-hand rule is flooded. And frankly speaking, for that, actually, I was sharing animations and videos with you because, Fleming rule is very difficult in the start. And it needs a physical interaction. You have to put your left hand on the table and you have to fix the things like current is going in the page. Can you recall for me in Fleming's left hand rule, what is the direction of current? The first finger is field, the second finger is current, and the thumb is the force.
That's really difficult to judge it from the screen.
But remember, it's a paper. You have to judge it from the paper. You can practice from animation, from live, anything you can do. But in the paper, I am. So you have to put can you put your left hand and
Is it D? D?
current is in the page and field is not to south. Are you putting your finger downward, the left hand finger?
Yes.
Because
As per my finger, the thumb is towards B, the first finger is towards C, and the middle one.
I tell you always a very important rule. I repeat my rule. Force will never take the direction of current. Force will never take the direction of magnetic field. Can you see D is in line with north to south line?
Yes.
Can you look at D? Can you look at D? Is it matching with the arrow of north to south green line?
Yeah, it is.
You see the arrow D, is it
Okay.
with north to south?
No, it is separated in middle.
No, arrow means direction. Look at the arrow on D. I put a question mark here, okay? Can you see the direction of the option D? The option D, look at the option D. I put a question mark here. Option D. And can you look that this arrow is parallel to the north to south arrow?
Yeah, it is.
It is. So remember a rule, a very helpful technique. The force will never take the direction of the magnetic field. It will never take the direction of the current. So B and D cannot be the answer. Why B and D cannot be the answer? Because they are in line with the arrow of the magnetic field. So if you solve, then you reach the answer C. Can you repeat a very powerful technique? Why we have rejected B and D?
Because it is parallel to the, like, it is same as the direction of magnetic force, and the current can't be there.
Force? No, no, not magnetic force, magnetic field.
Yes, magnetic field.
Read the question number 16. I can't hear you, sorry, some distraction. This distraction is there.
No.
Can, I think for 1 or 2 seconds wait, and you can write the answer on the chat. I am giving you the hint. C and D. C and D are out of race. C and D are cancelled. Why C and D are cancelled? A force cannot take the direction of the magnetic field. Force cannot take the direction of current. Force will always take the third perpendicular axis. So can you tell me why C and D are out of race?
Because it's like the same concept like the previous semester, right?
Now you're getting the idea na, that it is difficult, but not that much difficult. So now you have option left A and B. A means into the plane of the paper. B means out of the plane of the paper. So you have to put your left hand. The finger should be down, and magnetic field is north to south. So the force is coming into the plane of the paper.
Yeah. Okay, so then we can go on next question.
The diagram shows a wire placed between two magnetic poles of equal strength. A current passes through the wire in the direction shown. The current causes a downward force on the wire. He has given us the direction of the force. He has given us the direction of the current. Now you have to put a trial and error for the options. I am cancelling C and D.
Because a light can't be there.
No, look at the option. Are they north?
Yes, and not right.
There will be attraction or repulsion.
Attraction, but the
Nahin,
force goes downward.
not like poles, not like current, like poles. Do they attract or repel?
Repel.
Yes. So have to cancel out.
C and D will be cancelled for sure. Then
Let me make the arrows. Magnetic field is always from north to south.
if it is downward, then north to south, right? If it upward, south to north.
That's a good way to remembering it, and gradually you will understand that after cancelling the two options, how you get it. And once this topic will be discussed in your class, you will get it more easily, because in the class, the teacher will physically show your left hand, and it will be much easier for you to understand that actually how you put left hand. I will try to discuss it on video also, but obviously in a live class, teacher can also guide your hand just standing in front of you, and you can move your hand, because left hand rule is always challenging in our O-level physics. Now, I can test option A and B, force is downward.
And mine answer is B.
Sure. But force is going downward. Answer is A, not to south, because you know what happened? in case of north to south, when current is coming towards you, the magnetic force will be upward. Magnetic force will be upward. Can you, Hamad, again recall for me what are the fingers? What are the finger parameters? What is on first finger? What is on second finger?
The thumb determines the force.
Okay.
Then the first finger determines the current,
Hmm.
and
The second
the
finger is field and
second
the
finger
first
determines
finger
the,
is field.
yes sir.
First finger is the field.
Okay.
Thumb is equal to force. Thumb is equal to force. First
Okay.
finger is field and the second finger is
Magnetic something.
current.
Okay.
So can you look at B again carefully? Can you look at B again?
I
What
think
is
B
the
is
direction of magnetic field in B?
from north to south.
Very good. North to south. Now you are very close. I'm sharing you a diagram. You can look at the WhatsApp and you will get it in B. This is a diagram for B. This picture is for option B.
Oh wait. Okay.
Did you see the picture?
Yes sir, I'm seeing it.
Actually, now you know the biggest challenge. It looks very funny for many people. Now try to put your hand. Now try to put your hand in this style. Until you move your own hand, you will not get this topic. This topic will keep on troubling you until you try to put your hand.
But sir, how do you know that I'm putting the hand correct or wrong?
No, actually, in the start, everyone faces this problem because left hand rule. It is that's why I'm saying that once this topic will start in your class, you will get it much more easily because the teacher will show you the left hand in front of you. Now I have shown the current. Now are you able to align your own hand as I have sent you the picture? Left hand.
The thumb is towards the south.
The thumb is upward. In the picture
Yes.
I have shown you, the thumb is
The
upward.
thumb is upward, then the first finger is almost like pointing towards north,
Hmm.
and then the second finger is like towards eye, like towards my eyes.
Hmm. So now look at the diagram, then option A, because in the option A, the force will be downward. We need the force downward. In option A, the force will be downward.
Yes.
And in option B, force will be upward.
Okay. Sir, can you give me a minute?
Hmm.
But sir, if I try to use for the Fleming right hand rule for B. Then how would I do it?
Fleming's right hand rule for what?
B. The option B.
No, no. This is another confusion which you should clear. Fleming left hand rule is used when he's asking you to find the direction of force. Fleming right hand rule is for direction of current and magnetic field. Fleming right hand grip rule does not deal with the force. You always have to remember it's a left hand rule case. Now come on 18. Here you can use right hand rule. Two straight electrical conductors are parallel to one another. Each carries a current, one into the plane of the paper and one out of the plane of the paper. You have to see, you can open your notes. The currents which are in the same, the currents are not same. One is dot, one is cross. What is a dot and cross means? That one current is in the page.
Cross is into the page and dot is out of the page.
Yes, see this one. One current is out of the page and one current is in the page. Okay, now if currents are in opposite direction, do the wires attract each other or repel each other? Like currents, these are unlike currents. Unlike currents attract each other or repel each other.
Like will repel each other and like will attract each other.
Very good. Like wires, so if they repel each other, the two fields will merge or two fields will not merge. How you can manage these MCQs? I tell you easy way. Dot dot or cross cross merge. Dot cross never merge.
Okay.
But I tell you, dot
Dot cross will never merge.
dot dot cross cross, they are able to merge. But
So that's
dot,
like the same will merge and the unlike will not merge.
yes. So then you have to see the options.
So for the like the IGCSE like the board exams, like the full book will come or like some specific topics.
GCSE, if you are giving extended version and you are giving extended, I think, so you have to go, you have to face the whole book.
Oh, full book. Okay.
You have to face the whole book and there would be 3 papers. We are presently focusing on 2 papers. Now I'm thinking to start ATP with you because there are
Practical.
paper 4 and paper.
C should be the answer. D is wrong.
Question number 19.
Question number 19. Which is the direction of force?
Direction of the force on the wire due to the current. How can I determine, the current direction is given, already given. What is the direction of magnetic force, magnetic field? What is the direction of magnetic field?
Direction of magnetic.
Please tell me, what is the direction of magnetic field? Is it north to south?
Yes, not to south. Sir,
Yes.
no, not out. Then
What is the direction of magnetic field?
also the Fleming's left-hand rule, right?
Yes, but I am in the start. In the start, I'm cancelling B and D.
B and D are a nonsense as the concept we studied above.
They are in the direction of the field.
Sir, I'm getting it as a C, if I'm not wrong.
Can you look at the option B here? Option B.
Sir, is it C?
No. Look at this screen, and if you can memorize this figure, north to south, when current is coming you towards you, the force is upward. And here,
Oh, so here also it will be upwards.
yes, it is.
C.
The current is coming towards you, so the force is upward. Answer is A. Right. Why B and D are cancelled?
Because of the north and south, the current can't like to give them
Force cannot take,
the magnetic pole's direction.
yes, and also it cannot take the direction of, it cannot take the direction of current. Two long straight wires hang vertically close to each other. The wires carry currents in opposite direction. Which diagram shows the magnetic field pattern around the wire? Are they dot cross or dot dot, or what they are? What is the rule for solving these questions? Can you see the rule?
Yes, a dot cross will not merge and dot dot will merge. And x-axis will also merge. Cross cross and dot dot will merge and dot cross will not merge.
Good. And you can, if you want, you can copy this very important rule for MCQs, this one.
I have copied it.
So dot dot cross cross merge. So now can you see option, question number 21, which option suits us?
The wire current
One
carries
is
current
dot,
in.
one is cross. Can dot and cross merge?
No.
So option A and C are out.
Then the opposite, they take opposite current.
But now the tricky part is here, because you have to remember, because very good working can be done if you can once memorize with me two diagrams which I had given you when we were solving this chapter. If you can draw with me and you memorize them, draw with me, and then you will be able to do these type of questions. Now memorize this. Copy these two diagrams.
Sir, 1 second, a call. Or 1 second.
Yeah, no problem. Copy it comfortably, and this will be the last question for today. If
Sir, if
you,
I could ask that, you're teaching maths also, if I'm not wrong, right?
yes, I teach maths also.
But sir, how can you teach graph online? That's the biggest thing.
No, very simple. Actually, teaching graph is easy, because you can open normally all students have digital devices nowadays. So you share the graph and you tell students to open, and I open the screen and I start working it. Actually, left hand rule, right hand rule gives the problem, because you know why? Because you need a physical interaction for that, and you want, normally if it doesn't work, you know what I do? I go for a video call with the student, and I tell the student to have a video call with me, and then we can sit and we can fix the left hand rule. If the left hand rule doesn't work, like here we are facing this problem. So what about dot and cross? Now you can fix the BMC.
It's, is it D?
You're right. B is fine. But how you got B?
I already mentioned it, right?
Hmm?
Because of the currents in opposite direction.
But that is in D also. The main thing is the game of arrow. This is a very important thing which somehow you're not getting by now. Do not write it. Wait, please.
Yeah.
I make a red circle here, huh? Okay. And I make a red circle here. Is it matching? Cross,
Yes,
cross.
yes.
And I make a red circle here. And now match it with this one. I put a question mark. Is it?
Direction of arrows were wrong.
Hmm?
The arrows pointing were wrong.
Ah, now you get it. This is how we did. There is no problem of left hand rule, right hand rule. Now, simply learn these two diagrams. Simply learn that, then you are fine. Learn these two diagrams. You know how people learn it? Dot means clockwise, cross means anti-clockwise. Can you repeat before I stop the class?
Dot means clockwise and cross means anti-clockwise.
Yes, this is the best to tackle that. Dot cross means clockwise. Let me write it for you, and then I get the class over. Can you identify? Clockwise for me? The dot is clockwise or cross is
Dot is clockwise.
clockwise? Direction of clock.
Yes. And cross is anti-clockwise.
Are you sure? Put a clock with it.
What?
Put your if you have a clock there, clock with you presently. Any clock in the room, or
Yes, there is one on the wall.
so you can see the clock. Cross is clockwise. And anti-clock dot is anti-clock. Look at the arrows. The clock is clicking in the direction of cross figure. Can you compare it?
Is dot is clockwise or cross is clockwise?
I have written it for you now.
Yes, anti-clockwise. Okay, I remember it now.
But can you look at the clock in front of you also, and you understand what I'm saying? What is the meaning of clockwise actually? In the direction of clock. Clockwise means in the direction of clock.
Well,
Clockwise means against the clock. So we stop here, and you learn all this material which you have studied today. And this chapter will, inshallah, improve in the next class. For the time being, it's over. Thank you.